When the James Webb Space Telescope launched on Christmas Day 2021, scientists thought they knew what they'd find. They expected to see the first baby galaxies slowly forming, tiny black holes just getting started, and a universe that matched their textbooks perfectly. Instead, JWST delivered the scientific equivalent of walking into your garage and finding a fully grown elephant where you left your bicycle. In just 3 years, this incredible machine has shattered so many established theories that physicists are scrambling to rewrite the rules of the universe itself. Today, we're exploring 7 discoveries that have left scientists saying, "That's impossible." From galaxies that grew up way too fast to black holes that shouldn't exist yet. These aren't just pretty space pictures we're talking about. These are findings that could completely change how we understand reality itself. So buckle up, because we're about to explore how one telescope managed to turn modern physics upside down. One jaw-dropping discovery at a time. Let's start with something that sounds simple but is actually mind-blowing. JWST discovered planets with atmospheres that, according to everything we know about planetary science, should have been stripped away billions of years ago. Picture this. You have a planet called TOI 561b that's basically a molten lava world, getting blasted by radiation from its nearby star. It's so hot that iron would literally rain from the sky. According to our models, any atmosphere, that's the layer of gases surrounding a planet, should have been blown away faster than leaves in a hurricane. But JWST looked at this cosmic furnace and found it still has a substantial atmosphere clinging to it. It's like finding an ice cube that refuses to melt inside a blast furnace. This discovery is forcing scientists to completely rethink how atmospheres form and survive around planets. Even more surprising, JWST detected hydrogen sulfide, the chemical that makes rotten eggs smell terrible, in the atmosphere of another distant world. This was the first time we've ever found this molecule around an exoplanet, which is any planet orbiting a star other than our Sunday. These atmospheric discoveries might seem small, but they're huge red flags that our understanding of how planets evolve is fundamentally incomplete. Speaking of impossible physics, here's where things get really weird. JWST discovered that the early universe was forming stars in ways that should be physically impossible. In today's universe, when gas clouds collapse to form new stars, only about 10% of that gas actually becomes a star. The rest gets blown away or heated up too much to collapse further. Think of it like trying to make a snowball where 90% of the snow keeps falling out of your hands. But JWST found ancient galaxies that were converting nearly 100% of their available gas into stars. That's like making a perfect snowball where every single flake of snow sticks exactly where you want it. According to our physics, this level of efficiency is virtually impossible. These red monsters, as astronomers nicknamed them, were forming stars at nearly twice the rate that our current models say should be the maximum possible. It's as if these early cosmic star factories had some kind of secret technology that made them impossibly efficient. The implications are staggering. Either the laws of physics worked differently in the early universe, or we're missing some crucial piece of the puzzle about how stars actually form. Either way, it's back to the drawing board for stellar physics. This brings us to something that gets technical, but stick with me because it's absolutely fascinating. After the Big Bang, the explosive birth of our universe 13.8 billion years ago, the cosmos went through what scientists call the epoch of reionization. This is when the first stars began shining brightly, enough to strip electrons from hydrogen atoms throughout the universe, making space transparent instead of foggy. Scientists thought this process took its sweet time, ending around 1 billion years after the Big Bang. But JWST data suggests it actually finished 350 million years earlier. That's like expecting a marathon runner to finish in 4 hours and having them show up at the finish line in 2.5 hours instead. The problem is that to ionize, or electrically charge, all that hydrogen gas so quickly, you need an enormous amount of high-energy ultraviolet light. It's like trying to light up a massive dark warehouse, but discovering you did it with far fewer light bulbs than should be physically possible. This creates what scientists call a photon budget crisis. There simply weren't supposed to be enough energetic light particles in the early universe to get this job done so fast. Yet somehow, it happened anyway. But wait, because we're getting into the really mind-bending stuff. JWST discovered supermassive black holes, objects with the mass of billions of suns, existing just 700 million years after the Big Bang. To put that in perspective, that's when the universe was barely 5% of its current age. Here's why this is so shocking. Black holes are supposed to start small and grow slowly. The traditional theory says a massive star dies, creates a black hole maybe 10 times heavier than our sun, and then that black hole slowly feeds and merges with other black holes over billions of years to become supermassive. But the black holes JWST found are already mature giants, some containing 100 to 1,000 times more mass than the supermassive black hole at the center of our own Milky Way galaxy. It's like planting an acorn and finding a 1,000-year-old oak tree the next morning. There simply wasn't enough time for these cosmic monsters to grow so large using conventional methods. This discovery has revived interest in primordial black holes, theoretical objects that might have formed directly from the chaos of the early universe itself, rather than from dying stars. Some scientists are now proposing that these primordial black holes, weighing about 50 times more than our sun, acted as seeds that could rapidly grow into the giants we observe. It's a completely different formation mechanism that bypasses the usual slow growth rules entirely. This discovery has reignited one of the biggest controversies in modern physics. For decades, scientists have believed in dark matter, mysterious invisible material that makes up about 85% of all matter in the universe, but doesn't interact with light or ordinary matter in ways we can directly detect. The dark matter model predicts that early galaxies should start as tiny fragments that slowly merge together over cosmic time, like small streams gradually joining to form a river. But JWST is showing us something completely different. Large, bright, well-organized galaxies that seem to have assembled rapidly right from the start. This unexpected finding has given new life to an alternative theory called MOND, Modified Newtonian Dynamics, which suggests that instead of invisible dark matter, the laws of gravity themselves might work differently on cosmic scales. For over 2 decades, most scientists dismissed MOND as incorrect. But now, MOND supporters are saying, "I told you so," because their theory actually predicted exactly what JWST is observing. Stacy McGaugh, a physicist who has long advocated for MOND, couldn't hide his scientific satisfaction when the JWST data came in. The early galaxies JWST discovered were brighter and bigger than dark matter models predicted, but they matched MOND's predictions almost perfectly. This doesn't necessarily mean dark matter is wrong, but it does suggest that something fundamental is missing from our understanding of how cosmic structures form and evolve. There's another problem that's been keeping cosmologists, scientists who study the universe as a whole, awake at night. It's called the Hubble tension, and JWST has just confirmed that it's a real crisis. Here's the issue. Scientists have 2 different ways to measure how fast the universe is expanding. When they use one method, looking at the cosmic microwave background, that's the leftover heat from the Big Bang, they get one answer. When they use another method, measuring special stars called Cepheids, they get a completely different answer. The difference might sound small, but in cosmology, it's huge, like having two perfectly calibrated rulers that give you different measurements of the same table. JWST was supposed to help resolve this discrepancy by providing more accurate measurements. Instead, JWST confirmed that both measurements are correct within their own methods, which means our fundamental understanding of cosmic expansion is incomplete. The telescope observed over 1,000 Cepheid stars and matched previous measurements almost exactly, ruling out measurement errors as the cause of the tension. This crisis is so significant that scientists are proposing entirely new physics to explain it, including early dark energy, a mysterious repulsive force that operated only in the young universe. If true, this would represent one of the most important discoveries in cosmology since Einstein's general relativity. But perhaps the most shocking discovery of all is this. JWST found massive, mature galaxies existing just 500 to 800 million years after the Big Bang. Cosmic toddlers that were already the size of adults. These galactic giants are as large and organized as our Milky Way, but they existed when the universe was just a cosmic blink of an eye old. According to the standard model of cosmology, our best theory for how the universe evolved, these galaxies simply shouldn't exist yet. Think of it this way. If the universe's entire history was compressed into a single year, these galaxies would be like finding fully grown oak trees in early February, just days after you planted seeds in January. The Lambda CDM model, which is the scientific consensus about cosmic evolution, says galaxy formation should be a slow, gradual process taking billions of years. But JWST is showing us massive galaxies with stellar masses exceeding 10 billion times our Sun, complete with well-organized spiral structures, existing when the universe should barely have had time to form its first small galaxy fragments. Some of these early galaxies appear more massive than the Milky Way despite having billions fewer years to form and grow. If these measurements are correct, we're looking at a fundamental breakdown of our cosmological models. The numbers are so extreme that they would require these early galaxies to convert nearly 100% of their available matter into stars, an efficiency level that approaches the theoretical maximum. It's like finding a factory from the Stone Age that operates with modern industrial efficiency. This discovery is forcing scientists to consider radical alternatives, either something completely new about galaxy formation that we've never understood, or fundamental modifications to our cosmological models. Some researchers are even suggesting that the basic constants of physics might have been different in the early universe. These 7 discoveries from JWST represent more than just surprising observations. They potentially signal the need for new physics beyond our current understanding. The consistency of these challenges across multiple domains suggests that we may be missing fundamental pieces of the cosmic puzzle. The telescope's findings echo those pivotal moments in scientific history when new technology revealed phenomena that existing theories couldn't explain. Just like when the photoelectric effect led to quantum mechanics, or when Mercury's strange orbit confirmed Einstein's relativity, JWST's observations might be pointing toward the next great revolution in physics. What makes this moment particularly exciting is that many of these discoveries seem interconnected. A single unified explanation, whether it's early dark energy, modified gravity, primordial black holes, or entirely new physics, might resolve multiple cosmic puzzles simultaneously. Perhaps most remarkably, JWST has reminded us that the universe will always be more complex, more dynamic, and more surprising than we dare to imagine. Every time we think we have cosmic evolution figured out, nature shows us just how much we still don't know. The James Webb Space Telescope continues to peer deeper into space and time, and with each observation, It's becoming clear that the universe revealed by this incredible machine is not the orderly, predictable cosmos we thought we knew. Instead, it's a place where the impossible becomes routine, where every discovery has the potential to overturn centuries of scientific understanding. The age of cosmic discovery has only just begun, and if these first 3 years are any indication, JWST is going to keep delivering revelations that will force us to completely reimagine our place in an ever more mysterious universe. The theories it has already challenged may just be the beginning. The cosmos is clearly keeping many more secrets, and JWST stands ready to unveil them, one paradigm-shattering discovery at a time.